Hi everyone, in this video we'll be talking about the binomial theorem. Now the word binomial means two terms. The binomial theorem helps us to expand brackets with two terms such as x plus 2 raised to power 4, 2x minus 3y raised to power 3, or 2 minus 10x raised to power 8. Now by expanding brackets we know that the following holds. A plus b raised to power 0 equals 1. Now a plus b raised to power 1 gives us 1a plus 1b, or just a plus b. And a plus b raised to power 2 equals, that is, a plus b raised to power 2 equals a plus b times a plus b. And this gives us a times a gives us a squared, a times b gives us ab, b times a gives us ab again, and b times b, b squared. And this gives us a squared plus 2ab plus b squared. So a plus b squared is a squared plus 2ab plus b squared. Now to expand a plus b cubed, observe that this equals a plus b squared times a plus b. And a plus b squared is a squared plus 2ab plus b squared times a plus b. So we have b times b squared gives us b cubed. B times 2ab gives us 2ab squared. B times a squared gives us a squared b. A times b squared gives ab squared. A times 2ab gives 2a squared b. And a times a squared gives a cubed. And so we have b cubed plus 3ab squared plus 3a squared b, a cubed. This is the expansion for a plus b cubed. And so we can introduce the coefficient. The coefficient for a cubed here is 1, and for b cubed is also 1. So we have 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. So in a similar manner, we can obtain the expansion of a plus b raised to power 4 as this. Now, the numbers in front of each of the terms in these expansions are called coefficients. Now observe that these coefficients form a pattern, and this pattern is called the Pascal triangle. We have 1 here, 1, 1, and then we have 1. To get this, we had 1 plus 1 gives us 2, and we have 1 here. We also have 1 here. 1 plus 2 gives us 3. 2 plus 1 gives us 3, and then 1. So we have 1, 1. 1 plus 3 gives us 4. 3 plus 3 gives 6. 3 plus 1 gives 4. Now to obtain the term for n equals to 5, we have 1. 1 plus 4 gives 5. 4 plus 6 gives us 10. 6 plus 4 gives 10. 4 plus 1 gives 5. And then we have 1. So we can continue in this format to get for n equals to 6. Now, we also observe that, for instance, in the expansion of a plus b raised to power 4, the power of a decreases from left to right. We have a raised to power 4 here, a raised to power 3, a raised to power 2, a raised to power 1, and then a raised to power 0, which is equal to 1. And the power of b increases from left to right. Here it is b raised to power 0. Here it is b raised to power 1, b raised to power 2, b raised to power 3, and b raised to the power of 4. Now, also observe that the sum of the powers of a and b equals 4. So here we have 4 here. Here we have 3 plus 1 gives us 4. 2 plus 2 gives us 4. 1 plus 3 gives us 4. And then 4 here. Now with that, we can obtain the expansion of a plus b raised to power 5. Now from our Pascal triangle, we can write the coefficients as 1, 5, 10, 10, 5, and 1. Now the first term here is a, so we have a raised to power 5. Now the power of a decreases as we go from left to right. We have a raised to power 4 here, a raised to power 3, a raised to power 2, a raised to power 1, and here a raised to power 0, which is equals to 1. Now the power of b increases from left to right. So we have b raised to power 0 here, which is 1, plus b raised to power 1, plus b raised to power 2, plus b raised to power 3, and then we have b raised to power 4, and finally b raised to power 5. Now there's an interesting relationship between these numbers and the combination formula n combination r, or n choose r, which is defined as n factorial over r factorial times n minus r factorial. Now if you are not familiar with this, do not worry, we would see it how it is being done later on. Now for n equals to 0, 0 combination 0 equals 1. And then for n equals to 1, we have 1 combination 0 gives us 1, and 1 combination 1 also gives us 1. For n equals to 2, 2 combination 0 gives us 1, 2 combination 1 gives us 2, and 2 combination 2 gives us 1. For n equals to 3, we have 3 combination 0 here, 3 combination 1 equals to 3, 3 combination 2 equals to 3, 3 combination 3 equals 1. And for n equals to 4, we have 4 choose 0 gives us 1, 4 choose 1 is the same as 4, 4 choose 2, 4 choose 3, and this is the same as 4 choose 4. Now let's just pick this and see that 4 combination 2 equals to 6. So by definition, 4 combination 2 equals 4 factorial over 2 factorial times n minus r, that's 4 minus 2, which is also 2 factorial. And this is equal to, by definition, 4 factorial is 4 times 3 times 2 times 1 over 2 factorial is 2 times 1 times, then 2 factorial is also 2 times 1. So this cancels this. 2 into 2 is 1. 2 in 4 is 2. So 2 times 3 gives us 6. So we have shown that 4 choose 2 equals 6. And likewise, 4 choose 3 gives us 4. We can now see that, for instance, when n equals to 4, these coefficients can be replaced by these combination notation. So if I have a plus b to the power of n, this will be equal to, now let's write the coefficient first in terms of the combination formula. So we have n combination 0, n combination 1, n combination 2, n combination n minus 1, and n combination n. Now the power of a decreases from left to right. So we have a to the power of n a to the power of n minus 1, a to the power of n minus 2, this is a to the power of 1, and this is a to the power of 0, which is equal to 1. And the power of b increases from left to right. So this is b to the power of 0, which is 1, plus b to power 1, plus b to power 2, plus up to b to the power of n minus 1, plus b to the power of n. And so this statement is known as the binomial theorem. It states that for any positive integer n, a plus b to the power of n can be written as this. So let's see an example to illustrate this. So expand x plus 2 to the power of 4. So in this case, my a solution, a equals to x, b is 2, and our n is 4. So by the binomial theorem, we have x plus 2 to the power of 4 equals 4 combination 0. A is x, so we have x to the power of 4 plus 4, choose 1, x 4 minus 1, that's 3, times b is 2, plus 4 combination 2, x raised to the power of 4 minus 2, that's 2, b is 2, b squared, that's 2 squared, plus 4 combination 3, x to the power of 4 minus 3, that's 1, and then b to the power of 3, so that's 2 raised to power 3, plus 4 combination 4, b is 2, that's 2 raised to the power of 4. So observe that the power of x decreases from left to right, 4, 3, 2, 1, 0, while the power of b, which is 2, increases from left to right, 0, 1, 2, 3, and 4. And so this is equal to 4 choose 0 is 1. You can use your calculator to work that out, or we use the formula 4 choose 0 equals to 4 factorial over 0 factorial times 4 minus 0, which is 4 factorial. This is equal to 4 factorial over 0 factorial by definition equals 1 times 4 factorial. So 4 factorial cancels 4 factorial, and we have 1. So we have 1 here. This gives x raised to the power of 4 plus 4 combination 1. By definition, that is 4 factorial over 1 factorial times 4 minus 1, which is 3 factorial. And that gives us 4 factorial is 4 times 3 times 2 times 1 over 1 factorial is 1 times 3 factorial equals 3 times 2 times 1. So this cancels this, and we have 4 left. So 4 choose 1 is 4 s cubed times 2 plus 4 choose 2. Using the calculator, we see that this gives us 6 x squared times 2 to the power of 2 is 4 plus 4 combination 3 is 4 x times 2 cubed is 8 plus 4 combination 4 is 1. 2 to the power of 4 is 16. So this gives us x to the power of 4 plus 4 times 2, that's 8s cubed, plus 6 times 4 is 24x squared, plus 4 times 8 gives us 32x here, plus 16. And so this is the binomial expansion of x plus 2 to the power of 4. I hope you enjoyed this video. In the next video, we will see more examples on how to apply the binomial theorem. Thank you.